Here I have a Perseus and 3 Airspy HF Plus units. This one is modified and contains a pre-selector. The other two are without any modification on the hardware, but this one has firmware 1.2 and this one has the latest firmware 1.7 something. You will see that on the screen later. Each radio of these HF pluses have an attenuator in front of them, here, here and here. That's because I want to set the sensitivity for these HF plus to be the same as the sensitivity of the Perseus in order to make a fair comparison. Here I have a 6-way Wilkinson splitter with fairly good isolation between the ports. To improve further the isolation, I have a 6 dB attenuator, 6 dB or 2 times 3 dB in each port. So that improves the isolation because HF plus units, they can send out intermodulation so it will be seen by the other radios if I'm not careful like this. This Wilkinson splitter is fed by 2 signals. One that comes from this, what do you call it? This coupler, which is 20 dB attenuation and comes from one signal generator. And the signal that goes straight through, that comes from the antenna through an arrangement of filter, a notch filter and some amplifiers. So here comes the antenna signal. First is a 15 MHz low-pass filter to remove the FM band. Then there is 10 decibels of attenuation. I don't know if you can see that. And then there is another amplifier. And then the signal goes through this attenuator, stepped attenuator. And from there into this hybrid, where it is combined with the signal coming from signal generators. There are 3 signal generators connected here. 1, 2, 3. And they are combined in this 3-way hybrid. And then go through the second attenuator here and also into the hybrid. And the output of the hybrid goes through this notch filter. And there is a 15 MHz low-pass filter at the output of the notch filter. And from here, the signal goes into the 20 dB coupler and then into the Wilkinson 6-way splitter. So here is the schematic diagram. Antenna, low-pass filter, amplifier, 10 dB attenuation, another amplifier, stepped attenuator, and another amplifier. I don't remember if I mentioned that, but you can see it in the video. Then the hybrid. And the signal generators, 3 of them combined, the stepped attenuator, and also into the hybrid. And the hybrid is a 4-port device. It has to have a 50 ohm attenuator on one port. Then there's the notch filter, low pass filter, and the minus 20 dB coupler where the signal from another signal generator can be inserted. And this signal will be placed at the center of the notch where there is no noise from the antenna and where the signal generators would not pass through this way. Because of the notch, it blocks anything at 7.198 or something like that. And of course this coupler needs a 50 ohm termination. Then there is the 6-way Wilkinson splitter with 6 outputs. And they go to one into the Perseus, another into an oscilloscope, and another one into a spectrum analyzer. And then there are 3 more outputs. They all have a stepped attenuator and one of the HF plus units. And I will set these attenuators for the HF plus units to provide the same minimum discernible signal or the same noise figure as I have in the Perseus. In this video I will only show some preliminary results, and then I will make a couple of videos showing details on various aspects of this comparison, because it's a complex thing to compare receivers. There are many properties that are normally not tested. So what I do first is to turn on the antenna signal like this, and here we see some interference, but not here and not here, and of course not in the Perseus. A little bit more, and we have clearly lost performance here. This is the old firmware 1.2, and this is the unit without preselector, and this is the one with preselector. I think I have to make them more similar like this. So here we see very clearly interference, but not here and not here. And this is related to the image rejection, which wasn't so good in the first versions of the firmware. I can increase a little bit more the antenna signal. And of course, the problems we see here depend on what kind of signals are on the image frequency. And we can see the unit with the preselector is more happy than this one. I had now, oh, here, look. And of course, in the Perseus, you don't see anything. I now add 10 dB more signal. And then the desired signal, this one, has dropped. And, well, these images talk for themselves. I now remove the antenna signal and add 2 signals from these 2 signal generators. They are close to half the frequency. And I turn them on. And here you can see second order intermodulation. It is the overtone of one signal and of the other and the sum frequency. And it is pretty similar in these units. Of course, nothing in the Perseus, but the unit with the preselector, that is protected. So I add 10 more dB, and here we have serious problems, and here there is just a small signal. 10 more dB. Now I have here, and also in the Perseus, but not as strong as in the Airspy with the preselector. But you must remember, the Airspy has a much better noise figure. These extra attenuators are not adjusted yet. I switch from HF AGC to manual control and apply some attenuation. And you could see the desired signal went down a little bit. I go back again. But the noise floor went down by a similar amount, so the loss of sensitivity is small. But the intermodulation is significantly lower. And here at 12 dB, I have to turn on more signal. Like this, and try and you see attenuating too much degrades performance. So this looks like the optimum. I mean, the desired signal here and the undesired one here, I want the ratio between them to be as favorable as possible. So this is the one with the pre-selector, and I do the same for this unit. I have to turn down the signal level, something like this, and turn off the HF AGC. And more signal now. And here more attenuation gives a more favorable situation. So it seems that telephone is sometimes annoying. Anyway, now I have increased the level of the generators and I compare 18 dB with 12 dB, and it's quite clear that this is better. And then 24 dB, this is not good at all. So something undesirable happens. So probably 18 dB is the optimum. And then I try the other one, which here, it doesn't have any control. I can't do anything about it. So that is the old firmware didn't have the option of setting gain manually. So looking for the second order intermodulation, I attenuate. We have now the sum frequency and the desired signal approximately equal. And I attenuate 10 dB. And that means 20 dB for the second order intermodulation. It should. But there is AGC. And then 10 more dB. So we have 20 dB worse here. Now that is with no attenuation. I mean, that is with a much better noise figure than the noise figure of the Perseus. I bring up the levels. Here we have third order intermodulation, and here also, and of course here. The pre-selector doesn't make any difference. And we have it here in the Perseus also. That is digital feedback, so I continue upwards like that. and you can see the third order intermodulation, and you have it in the Perseus. I can add some antenna signal, and then it disappears in the Perseus, and it actually goes down in the HF plus units as well, but not as much. And more signal level on the signal generators, which reduces the problem in the Perseus, but now third order is similar to the desired signal in the HF plus units, and 10 more dB. These are fairly similar. They differ probably because of different gain settings. This one is not so good, means here the old firmware where I cannot adjust anything, it's not so optimized. I will look for what is the optimum gain setting here where I have manual gain. Does it change anything? Yes. For third order, the optimum is 18 dB in this unit, and it's the same for this one. So I think there is a small contribution of second order intermodulation from the capacitors in the preselector. Whether it is worth the cost of using better capacitors is beyond my judgment. I'm now listening to the Perseus, and I'm evaluating signal to noise ratio on the audio by use of Limrod. And I have adjusted the scale to show 0 for the noise figure of the Perseus. And now I will switch off the Perseus and switch on this one, which is the HF Plus that has the preselector. And as you can see, the noise figure is not quite as good, and that's because I have 18 dB, which was optimum for intermodulation. I pull it to 12 dB instead, and then the noise figure is about 2 dB better than required. So I will set the attenuator for 2 dB on this unit. And, well, the frequency differs a little bit. This one has 18 dB of attenuation, which happens to be optimum for IM3 and also IM2. And the noise figure is 2 decibels too good. So I have to attenuate by 2 dB for this unit. And finally, the old firmware where I cannot adjust anything. I have to set the frequency, and the noise figure is 9 decibels better than the Perseus, so I have to attenuate by 9 dB here. The attenuators were already on 7 dB, so I have to change and add or subtract something. The 1.2 firmware here has now 16 decibels of attenuation. The modified unit with the preselector has 6 decibels, and the unit without the preselector but with the latest firmware has 9 decibels of attenuation. So I have set the attenuation to 18 dB in the unit with the preselector, because that optimizes third order intermodulation and it doesn't destroy the second order intermodulation properties. So now I can look again what happens when I bring up antenna signals here. And we obviously have problems, not so big, but some problems here. And this is unacceptable to all the units, but not to the Perseus. And of course, what I want to do is to look at the signal to noise ratio of the desired signal. So right now it is the unit with the preselector, and I read -1 dB here on the scale, or close to 0. I remove the antenna signals. Difference very small. So it's like this, and then off with that, and I bring the firmware 1.2. And here you can see that the signal to noise ratio is degraded by about 4 dB. And finally, sorry, I have to, and here the same firmware, the latest firmware, but the unmodified unit. And I have to set the frequency right. And there are some problems, but not as much as with the old firmware. And if you look here we have some odd problems. Also here, but not as strong. The difference now is not so big between the units, because at this particular moment in time there isn't any problem with the mirror image signals. That was the problem with the original firmware.